we have learnt the complete detailing of zero order reaction. Now we've also learned the examples of zero order reaction. Now let us do this numerical. So what does the numerical say? The decomposition of ammonia. We've already written this example, isn't it? Decomposition of ammonia as under zero order examples. So the same numerical, that is the reason I've given you that example there. The decomposition of ammonia on platinum surface is a zero order reaction. That is understood. What are the rates of production of N2 and H2 if the rate constant is 2.45 in 10 to the -4 mole per liter second inverse, that is time inverse. So what do they want us to find out? They want us to find out the rates of the production of N2 and H2, correct? Now let us write. As soon as such question is given to you, try to first write your solution. Try to first write the equation. What equation? Stoichiometric equation. What is stoichiometry? A balanced equation. Now right. So what is the decomposition of ammonia? So NH3 gaseous state. It will decompose into N2 gaseous state plus hydrogen gaseous state. Correct. So first balance it. Stoichiometry I said, and nitrogen is 2 here, so I'm writing 2 here. So hydrogen has become 6, so I'm going to write 3. This is important. Without balancing, please don't start doing the zero order kinetics. A reaction, whatever reaction, try to balance a stoichiometric equation, then only do it. Now, what did they say? How much is the rate constant? K is equal to 2.5 into 10 to the -4 mole liter second inverse. Now, if I write the equation for this, how rate is equal to, for this is the reactant minus half, correct, delta concentration of ammonia divided by the change in time, which is equal to, there is nothing, no coefficient, plus change in concentration of nitrogen by change in time, which is equal to, there is a coefficient 1/3 change in concentration of the reactant by product by done. Yes. Now what should I find out? I have to find out for this one and I have to find out for this one. Now basically what did they said? They say they've already said the rate of the production or with the rate constant of this. Correct? They've already given me the answer that the rates of production of N2 and H2 is this. Right? Now this particular, when I take the rate constant for this particular one, because already this is given, so I'll write rate is equal to delta N2 divided by is equal to 2.5 into 10 to the -4 mole liter inverse second inverse. Done. Nitrogen is done. Now this is for nitrogen. Now I have to find it for hydrogen. Hydrogen, how much is this? It is equal to, how much is this? 1/3 delta hydrogen divided by delta T, which is equal to 2.5 into 10 to the -4 mole liter inverse. Now I have to find out for this whole thing. I have to find out. Now you're going to cross multiply with this, yes or no? Because when I take this out, this gets multiplied with this. What do you get now? 3 into 2.5 into 10 to the -4 mole liter inverse second inverse. You get an answer of 7.5 into 10 to the -4 mole liter inverse second inverse, because that is the zero order reaction. Let me come back and see what I have done. First, according to the question given, I have written a balanced reaction. After writing a balanced reaction, I have written an equation. According to that particular reaction, the rate of the reaction depends on this factor. Already they have given me the rate constant for nitrogen, means they have given it for generally saying the production rates of production. During the rates of production, the rate constant was this. So I have written for nitrogen. Now I very well know for hydrogen the rate of the reaction is equal to 1/3 according to the stoichiometric equation. So the whole 1/3 into this quantity, and what did I do? To get this whole quantity here, I pick this hydrogen here and I cross multiply with this number. I am getting an answer of 7.5 into 10 to the -4. Yes, so this is your rate of formation of your hydrogen. Yes, let us come back and do one more numerical on zero order reaction. So we have learned the rate equation, we have learned the units, we have also done the graphical representation of zero order. Then I've also given you a list of examples, like you can just remember 2 or 3 examples for each order of the reaction, and then we have done numerical. Let me do one more numerical based on this. More than that, you will not be questioned on zero order reaction. So let us come back. So let us read the question. The rate constant of a reaction of zero order. So rate constant of a reaction zero order is given to us. K is given to me. So as soon as you see this particular unit, mole, liter inverse, second inverse, that is basically the unit for zero order reaction. That is equal to 0.03 mole, liter inverse, second inverse. Done. How long will it take? So what should I find out? I have to find out time. For the initial concentration of A, so they've given A as a reactant to fall from 0.1 molar to 0.075 molar. So 0.1 molar, they've given the concentration of A, how much? From 0.1 molar, it has gone to 0.075. So simple, nothing to do, just write the equation. What is the equation which we have found out for rate constant zero order? K is equal to concentration of R naught, initial concentration minus concentration of the final reactant, divided by time, isn't it? So what should I find out now? I have to find out the time. It's cross multiply. It's a very simple numerical basically. K is equal to R naught by R minus K. Now substitute the values. R naught from this to this, isn't it? So R naught was 0.1 minus 0.075 molar. Try to put this molar so that you're complete with the numerical, divided by how much is the rate constant value given is 0.03 mole, liter inverse, second inverse. So when I solve this particular question, I think you'll be getting an answer now. Yeah, see, this is molar, isn't it? So what is molar? Molar means moles per or mole liter inverse. Yes or no? So this also mole liter inverse. So anything will do. Now, when I solve this whole numerical, you'll get an answer of 8.3 because it is time, seconds. Simple numerical. Just let us come back and see. They've given me this data. They've asked me to find out T. So now this is your rate constant or rate equation according to the rate law. I've substituted the values of K, which is given to me as 0.03. Initial was given to me as 0.1. I've substituted in this. Then final was given to me as 0.05. That also done. After calculating, I've got a time. They've asked me this. So I've got 8.3 seconds. That is your answer.